In the systems lifecycle, we're moving on to documentation here. This may seem like quite a trivial subject in the large scheme of things when you look at systems analysis from the outside and you start to realize that it's about looking at an existing system, finding what the problem is through analysis, then designing something, agreeing that that's okay, and then actually implementing that, then going through some testing of that to see if it does the job that you intended it to do. It may seem like a bit bizarre to suddenly start lumping documentation in here, but in fact it's absolutely crucial, and that's what we're going to look at here. Now, it may seem a little bizarre to be asking that question of what does documentation cover first of all before you even start to look at what the specific pieces of documentation are that are produced. But I think if you look at that, it allows you to reflect on all the work that's been covered so far, and in reading those questions there, it should start to trigger in your mind the different elements of systems analysis we've looked at, especially when you start to think of individual questions like that. It should trigger memories of the specific elements. If it doesn't, you need to go back and revise the different elements of the system's life cycle, because it's clear when you look at that which bit you're talking about. Number one's talking about a particular bit, number two's talking about another bit, and three, and so on. But especially in those early stages 1, 2 and 3, it should be triggering exact specific elements in the systems analysis lifecycle. If it doesn't, go back and look through the other elements again, either through the previous vodcasts that are provided, or the notes, or both. And if you read this alongside the notes, as you should do always with this, and all the reading around it, you'll see how it all begins to fit together. So relating back to the previous slide when we asked the question of what does documentation cover, this particular slide, what documentation is there, really answers those questions. We've basically got a requirements spec, and that goes back to analysis in the system's life cycle, and then the production of a design specification, that piece of documentation that comes from the design element. The program specs, and indeed some of the technical documentation will come through implementation. Now, I'm quite aware I didn't cover implementation as a specific vodcast from the system's life cycle, and there's really no need, because that's just the bit where the programmers put things together and develop the system. That could be a small job, a medium-sized job, a large job. There could be a team of people, it could be a couple of people, indeed it could be part of the work of the actual person who did the analysis and the design. It depends on the scale of the operation, and some of the technical documentation will come through that, but the evaluation will produce some of the technical documentation as well, and from the implementation and evaluation will come the user documentation, the last of these. As already mentioned, program specification, program specs as I've called them here, are put together at the implementation stage. So if you try and imagine you've got programmers sat there who may be working on different elements of a system. Let's look at it in terms of quite a medium-sized to large-sized system, and they're all working on their different elements, and then there's somebody trying to coordinate activities. Now, it could be that a programmer has to name a variable, for instance. Now, at this stage you may be thinking to yourself, what's he talking about? But in programming this is quite common. Now, it may be that one department of this business or this organisation calls something by a particular name, and they want to carry that forward, or a programmer wants to give a variable a name, but it could be that that same name is used again by someone else, and that's going to cause confusion. So you have to make sure that the understanding of what particular variables are is coordinated by everyone, so that the same names aren't used for two completely different things, which could cause conflicts, confusion, and indeed there's some understanding of exactly what's in the new system and how it correlates to the old system as well. So technical documentation is largely made up of three things. They may not always be in there, all these three things, but commonly they are. And I've tried to give you some understanding of this graphically rather than just list them out. This will suit some of you, but you might want to just list them out of bullet points if that's a better way to learn. I've tried to put some symbology on this so that you can understand that program specs and the program itself and hardware configurations are the three elements. As I say, it doesn't matter whether you think of it graphically like that or you think of it in terms of the actual bullet points. that are there. It's just that's the three common things, and that's really what you need to memorize. What is absolutely vital though for technical documentation is that you remember the words technical. Technical is what it's about. It's for people who are going to be involved in maintaining or further developing the system. If you have trouble remembering more than one point, just think of it in terms of maintenance. In other words, who's going to be coming back and fixing things when it goes wrong and everything goes wrong? If you think of it in terms of the network you work on in a college or a school, say the school you're at the moment, think of the job that the technicians do in terms of finding out problems, looking at where adding things or installing things. They want to know what's previously been done. They want to know the specifications of a certain program or the architecture of the network in a particular area, what relates to what's talking to what, and all these kinds of things. They want to know what's been done beforehand. So if we're talking in terms of programming, we need to know the rules. We need to know all notes, reasons that certain things have happened in the past. So this is no way intended for anybody who's using the system, for the people sat there doing the job from day to day, in other words inputting data, taking things out. This is for people behind the scenes, the technical people, hence the name technical documentation. Again, here I've tried to use some symbology to make it easier for some of you to understand. If you remember that the I on the left hand side is input and the O on the right hand side is output, I've used them before. And then we've got some way of representing installation and some way of representing error messages there. Second from the left and second from the right as well. So this is for user documentation, and those are the four really key elements of user documentation. If you've ever read a manual, this is really what's in any manual for any piece of software. For a game you may have bought, for Windows, for Microsoft Office, although a lot of the times this is given on a CD now, or you can access it via the web. Traditionally these would be given in paper form. It doesn't really matter, and indeed some of these in a system that's created by any systems analyst now would be given online or would be given on screen. But the important point is to look at the fact that it is user documentation. It's for people using the system to input, to get things out, to indeed install the system or reinstall if they had to do that as well, although we could be getting into the technical things there as well, and any error messages that come up, so that it allows them to keep using the system. Obviously some of those error messages may relate to technical things, and that's something they may have to pass back to the technician who may have a more insight to this, so there will be some crossover, but there's a clear definition between user documentation and technical documentation. That's for people at the front end using the software, the other one's for people who have to maintain, fix, develop.